Welcome to Nick Does Maths. We're doing some circular motion today. What have I got for you? My very best at 3D drawing. I tried. We have a hemispherical bowl. That's not an easy one to say. It is smooth. All right, we have a particle of mass m at point P, and it is rotating round the inside of the bowl at angular velocity omega. Notice I haven't written down the whole question. We're just going to do it off the diagram. To help it with that, it is attached by a string length L to the bottom of the bowl. This string makes an angle alpha with where it's fixed, and it's fixed right here at the bottom on the line of symmetry, very much the way we'd think it is. We need to show that the contact force at P is mg plus 2mr omega squared cos squared alpha. Easy peasy, squeeze the lemon. First thing we need to do is let's put some forces on here. So there is the weight of the particle. There is going to be a reaction force. All right, there is a reaction force there. And as we know from geometry, it will be heading towards the center of the sphere, right? Because tangent, whatever, tangent and the normal are perpendicular. Tangent and the radius are perpendicular. There we go. And this is why we need it to be smooth, because then I am just heading straight into the middle. And we finally have some tension here in this string. Okay, now some tension in the string. Let's put together, I think we probably need a little bit of geometry first to figure out what L is, because L remains an unknown, but basically I need to link R, L, and alpha. So let's start with that. That's going to be R, and that's going to be R. All right, all radiuses of my sphere. So let's put these down so I can stop clutching them like my life depends on it. What could we do? We could probably find a few things here, but the obvious one is, as much as I hate it, let's do some cosine rule. R squared is R squared plus L squared minus 2RL cos alpha. Oh, I suppose that tells me that L is 2R cos alpha. Hopefully that works. Okay, number one. That's going to help me why? Why is that going to help me? It probably will in a second. Because I need some angles, basically, don't I? I need some angles. Okay, I need some angles. I need, what else do I need? Let's get green out for this. If I pop that there, I need that. That is the radius of my turning, because if I'm doing circular motion like this, that is the actual radius of my circular motion. I've run out of R's. I don't know, call it D. Call that distance there D. We'll deal with that in a second. And we're going to want to split this R into components. So we need an idea of what that angle there is. Okay, fine. We'll figure that one out. Fine. Let's just see what bits we need, and then we'll figure them out in a second. So let's look at forces this way. The other thing that is quite clear from this is that that angle there is alpha as well. Yes, alternate angles. So R sine theta is equal to mg plus t cos alpha. Okay, so we're going to want to get rid of this theta in a second, obviously, because my thing here doesn't have a theta in it, so we'll do what we can. And then our forces going towards the center, right? What forces are going towards the center of my circular motion? I've got an R cos theta, and I've got a t sine alpha. That is md omega squared. Right. So what could I do? Bit of geometry here. D is L sine alpha. So let's do a little bit of this and then we'll plug it all in. D is L sine alpha, and L we've got up here. So there's 2R cos alpha sine alpha. Okay, that's quite nice. And then we probably want to do something with theta. Well, okay. Well, we can say that cos theta is d over r, which is 2 cos alpha sine alpha. Yes. And then probably want a sine theta in there, don't we? I mean, it's just 1 minus that squared, isn't it? Well, that is just sine of 2 alpha. So sine theta is square root of 1 minus cos squared theta. So that's just going to come out as cos 2 alpha, and I'll deal with that as and when, because it looks like I'm not going to want it in that exact form, but let's see where we go with it. Okay, I think I've got everything to plug into where I want it. So, which one am I most likely to be using? Well, I don't want any t's. So I don't want any t's, and I don't want these sine thetas and cos alphas, but again, deal with that in just a second. So let's get rid of the t's. How are we going to do that? Times this one by sine alpha, times that one by cos alpha. Sure, why not? So, and then subtract them and see what happens. All right, call this equation 1, call this equation 2. We're going to do equation 1 times sine alpha minus equation 2 times cos alpha. Which tells me that r sine theta sine alpha minus md omega squared cos alpha is equal to mg sine alpha minus r cos theta sine alpha. Okay. So, because r is what I'm looking for, so that's quite good actually. Okay, so r times sine theta sine alpha plus cos theta sine alpha is equal to mg sine alpha plus md omega squared cos alpha. Okay. Now we're going to have to use some of these. So what's cos theta sine alpha if I go on to here? Cos theta sine alpha. So cos theta sine alpha is 2 cos alpha sine squared alpha. Sine theta sine alpha which one do I want? Which form of that do I want? None of them really. Let's go 1 minus 2 cos squared. Times by sine alpha Okay. Ah, I can divide everything through by sine alpha. Yes. Yes. Yeah. So in fact, hang on. I've done this a little bit wonky as well. So let's do that again. Because it's number 1 times sine alpha, so sine theta sine alpha, and number 2 times cos theta, so it should be cos theta cos alpha. So that should be cos theta cos alpha. But that's still fine. That's still fine. Because what's D? I think D had a sine alpha in it as well. D had a sine alpha in it as well. Okay, so we don't really have a choice here, but we're just going to have to go for it. So mg sine alpha. Now, what did you say D was? That is 2m r cos squared alpha. Oh, there's some good stuff coming out here. Might be running out of space. Might be okay. And then over on this side, let's just do this over here because I do not have the space. So sine theta, we said sine theta was cos 2 alpha. Sine alpha, that's fine. I can deal with that. And cos theta was 2 cos alpha sine alpha. So 2 cos squared alpha sine alpha. Right? Cos theta, cos alpha, 2 cos squared sine alpha. All right. I think something's gone a bit wonky here, which we're going to try and fix, because otherwise I think we have everything we want here. If I can just cancel out a sine alpha here, so it's this side here that appears to have gone a little bit wonky. Now, is it because, in fact, this could be a plus or minus? Now, which one do I want? Ooh. So maybe that's my issue here, is that me trying to do that is my problem. Ooh. So maybe instead of this, maybe instead of that, we want sine alpha is that length there. Now that length there is r minus what's that? Oh. Is it minus cos 2 alpha? Why would I want the minus cos 2 alpha? Because I do get the plus or minus in there. So I'm just saying it would make this work out the way I want it to. No, it's fine. It's fine. Am I just having a stroke? No, because that's cos 2 alpha is 2 cos squared minus 1, and I want that to be 1 minus 2 cos squared. So all of that comes out as sine alpha, in fact, if I do this properly. So if I do that, that just comes out as sine alpha. Now, why that is, I'm not desperately satisfied with right now this second, but we're going to crack on with the question and try and figure it out afterwards. So why would that need to be that? But either way, we get our reaction forces mg plus 2mr omega squared cos squared alpha. We just need to go back to the geometry. We'll do that at the end. We'll do that at the end. Let's not let this slow us down. Deduce all of that. Okay, so that is R. Well, we know that the reaction force has to be positive. We know that the reaction force has to be positive, and this is a string, so the tension has to be positive. So the tension has to be positive. So let's come back up here. Let's come back up here. I'm going to regret this so hard in a second, erasing all of this. So really what we want is we want T to be positive. Now, we've said R is all of that. Now we need R to be positive, and that's just going to happen because positive, 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 not a problem for me. What I do need though is T to be positive. So T cos alpha is R sine theta minus mg. And I think where we're going to go with this is we're going to make that positive. Right. So T cos alpha is R we need a bit more space. So T cos alpha is R sine theta plus 2mr omega squared cos squared alpha sine theta minus mg. And you know what? I cannot abide this any longer. So let's figure this out. This once for all, let's figure out the relationship between alpha and what's it? Now the real thing to note is that all of that there is alpha. Is to note that all of that angle there is alpha. So how could I link these two things? Yes. That angle there is 180, forgive me for working in degrees, minus 2 alpha. So theta, so we can write that down here, theta plus 180 minus 2 alpha is equal to 90 degrees. So theta is 2 alpha take away 90. And there we have it. And now we have what we want. And now this is probably going to save us a whole load of grief if I'd just done that from the beginning. Fine. So sine theta is sine of 2 alpha minus 90. Which is minus cos 2 alpha. Awesome, I feel a lot better about life now. Sometimes you just need to take a step back. Right. Now, does that help me? Does that help me? Well, probably. Cos alpha is going to be positive. So really, all I need is for all of this to be positive. Yes. Yes. So this is mg times sine theta minus 1 plus 2mr omega squared cos squared alpha sine theta. Or we got something going on here. Now, what is sine theta minus 1? Sine theta minus 1 is 1 minus cos 2 alpha minus 1. But cos 2 alpha minus 1 cos 2 alpha minus cos 2 alpha minus 1. Cos 2 alpha is 2 cos squared plus 1. That's minus 2 cos squared alpha mg plus 2mr omega squared cos squared alpha sine theta. What do I want? I need that to be positive. I need that to be positive. All right, rewind. After a little bit more thought, I've just got too many sine alphas and cos alphas going on. So instead, we're going to have a little look-see at equation 2 here. Because in fact, remember, cos theta was sine 2 alpha, so that is r times 2 sine alpha cos alpha plus t sine alpha. And d was 2r cos alpha sine alpha. There's an m in there and an omega squared. And we'll see that a whole bunch of sine alphas cancel out. So that tells me that t is 2r cos alpha m omega squared minus 2r cos alpha. Now that needs to be positive, and this is where this condition is going to come from. Now, 2 is positive, cos alpha is positive. So what I get is that r m omega squared minus r has to be positive. Now, that is r m omega squared minus mg minus 2mr omega squared cos squared alpha. That all has to be positive. And there is a cos squared in my thing, so that's fine. The m's are going to go away. So what do I need? I need that to be negative. So that tells me I'll move the g over to that side. I can take an r omega squared out of these ones. So r omega squared, 1 minus 2 cos squared alpha is bigger than g. Tricky one, that one. A lot of geometry going on. Brain go mushy. Tell me if you picked out any other mistakes. That was a really, really interesting question. I hope you enjoyed it. Don't forget to click like and subscribe. Join me next time here at Nick Does Maths.